Hey, all right, we're going to look at some multiplication. Multiplication is going to be very important for us. We're going to start doing a thing called combinatorics, which in essence is different ways of counting. When we have data, we need to count that data up, and we have to also kind of figure out probabilities. And so counting things is important, and some of the things we count get very large. So, for example, I'm just going to show an example, and then I'm going to go into some of the mathematics we need to help us with this. If I go to a wedding and they offer me a menu of beef, or roast beef, right? Um, Chicken breast, and salmon, right? Three choices. We won't have a vegetarian option in, sorry. Um, and so you pick your main dish. Then you usually pick your side. Are you going to have potato? Um, Rice? And what's another good starch? We'll say potato, rice. We'll say baked potato or mashed potato. And then you can have corn, peas, or carrots, cooked carrots. Right? Let's go for everything's like similar colors, so I would say cooked carrots. And then you can have pie, cake, or ice cream. Right, and we've all been to places where you get these what seem to be really small menus. But if I choose roast beef, then I have three options I can choose for my side. So I'm going to do roast beef, mashed potato, peas, and pie. I'm in the mood for pie. We'll do pie. And that's one set of options. Well, another way I could do it is I could choose roast beef, but then I could get rice, corn, and pie again. And so the number of options, or the things I have to count, goes up rather quickly. And to do this, what we kind of have to think of is I have three options here. So I have three things. Each of those options gives me three more. So I multiply by 3, because 3 times 3. But each of these three options gives me 3 more. And each of these three options give me 3 more. And I have this string of multiplications I can do. And so I've counted up a large quantity of different types of menus I can get from this theoretical wedding. And I've turned it into a way of writing multiple multiplications. Multiple multiplications. Yeah, multiple multiplications. And because I made sure my menu items are the exact same amount, we write this rather simply as 3 to the 4th. Because I said I multiplied 3 4 times. And so one of the things we can do is we can convert multiplications where the factor is repeated into exponents. It's easier to enter on the calculator. It's easier to write down. It's easier to keep track of. And we're going to find that we're counting large quantities of things. Multiplication and exponents are going to help us a lot. And so that's what we want to look for, ways to make our notation better. I'm running to my calculator here because I know 3 times 3 is 9, and 3 times 9, so 3 times 3 is 9, which leaves me these two 3's over here. Whoops. Sorry. And these two 3's are 9, so 9 times 9, that's 81. 3 to the 4th is 81. But that's a lot of steps when I go in the calculator, type in 3 to the 4th, and get 81. And so with just these 4 slots with 3 options each, there are 81 different meals you can make. Yeah. It's a thing we're going to look into in much more detail in the statistics class, but I hope you can appreciate why I'm focusing on some rules of multiplication here, because it's going to be something we're going to see a lot of. And so the first thing we want to look at, and again, I'm doing the same thing here. I've put some worksheets up that practice this, and I'm just kind of following the worksheets as an idea of what we want to look at, is we can sometimes get a whole bunch of numbers coming across Oops, times 4, times 4. I'm using dots for multiplication. And I guess the thing I want to do is, if this is the math problem I have in front of me, besides scream and twirl my head around a bit, is I notice that some factors are repeated. And so I'm going to use my notation to help me here. I'm going to, well, 3 and 5 aren't repeated, so I want to put those out front. And then I have 3 multiplications of 4, so I'll turn that to 4 to the third power. And then I have 1, 2, 3, 4, 5, 6 multiplications of 7. I'll turn that to 7 to the 6th power. This is easier to write, and it's fairly quick to type in on my calculator. So let me see if I can get that working here. 2 seconds as I open up the calculator of doom. There it is. Dun dun. All right, now let me get it over so you can see the calculator of doom. Where did calculator of doom go? Here. Nope, not yet. 2 seconds. Calculator doom. There we go. That's better. Calculator doom. Okay. Virtual calculator. And so the problem I had, let's look back at it again, was I have 3 times 5 times 4 cubed times 6 or 7 to the 6th power. And so what I want to do here is I'll go back to this, clear that out, and so I had 5 times 3. I hit the wrong button. I won't worry about perfection here. I'll come back here, and back up. Hey, it's back on. On, good. Let's try that again without me hitting the quit button. So 5 times 3 times 4. And to raise things to a power, I hit the up arrow, and I hit the number 3. Then I have to hit this arrow to get back down, and that's times 7 to the 6th power. And I hit the right arrow again to get back down, and I hit enter, and I get my really, really big number. What is that? That's 112,943,040. And we're going to see numbers like that. Okay. We're going to see numbers that get big because the number of combinations that we have, the possible combinations we have, oops, 943,040. Put my commas in so I can say it. So 112,943,040. The number of combinations of things we have add up rather quickly. So we have to get comfortable with our multiplying and putting it in this compact notation. And so gathering how many times the same number is multiplied is very helpful. The other thing that we're going to run into is there's 2 sides to probability. There's loads and loads of counting, and counting that comes to multiplication, but there's also thinking about your odds of things or how often something happens. And we tend to write that, well, we saw it already when we did the relative frequency. Relative frequency was the normal frequency divided by the number of things we had. And this turns into a fraction. And we can talk about that fraction in different ways. We can talk about it as a percentage or a decimal. For example, if I am giving an exam, and I'll make it out of 10 points, and you get 4 out of the 10 points. Right? We can write that as a fraction, 4 over 10. Well, it's not in its simplest form, and so that's 2/5, but that also has a decimal representation, and that's 0.4. I'm running on the calculator, it's 0.4, it's exact. We think of that as being 40%. We have this dancing. I talked about percentage a video or 2 ago, but I moved the decimal place over twice, and it's 40%. They all mean the same thing. We just have different language, and we're used to communicating about them differently. I think percents seem easier to say. It comes, the word per means to divide, and cent means 100. So percent literally means to divide by 100. And that's what moving the decimal place over 2 does, is divides by 100, right? I have 40 out of 100. I move the decimal place 2 to the left, and I get 0.4. And so it's just a compact way of talking about it. But sometimes our fractions aren't nice to us. 1 over 3, if I plug that into a calculator, I get 0.333333333, and it keeps going. It fills up my calculator screen. And we actually call this a repeating decimal. It repeats forever. And there are certain fractions that do that. And so one of the things that we'll see happen is some of our numbers calculate out nicely to exact numbers, and others have this repeating form. And so what we can talk about is when they are an exact answer, which 1/3 is an exact answer and it's an exact number. But this 0.333 is an approximation. When we approximate, we put a wavy equal sign on it to say it's about this number. It's close. We had to round or do something. And so I'll use the examples on here. Sometimes we have to approximate. So if I take 3/8 as an example, and I'm going to use the long division algorithm for it. So I'll put 3 divided by 8, and I'll put my decimal point in there. I'll fire it up here. And so it goes into 3 0 times, so I'll borrow a 0. And 8 goes into that 3 times. 3 times 8 is 24. When I subtract, I get a 6, so I'll borrow another 0. And that gives me 7. Because 7 times 8 is 56. And that gives me, 50. I said 56, and I wrote 54. That gives me 4, and I bring down a 0. And that divides 5 times, and that's 40. And notice I have no remainder. And so this is an exact result. 3/8 is exactly 0.375. And so I use a normal equal sign, and it's exact. Well, let's use a neighboring fraction that isn't exact. Again, I'm following along with the worksheet here. I'll change colors. 3/7. I'm going to use the same division algorithm to see what's going on. I'm going to take 3, and I'm going to divide it by 7. 7 goes into 30 4 times, and I get 28. That gives me 2. I'll borrow a 0. Goes into that twice, which gives me 14, which leaves 6. I'll borrow another 0. Goes into that 8 times. I have to scroll up here, which gives me 56. Borrow 4. So I'll have to borrow another 0. Goes into that 5 times, which gives me 35. That leaves 5. I'll borrow another 0. Goes into that 7 times, which leaves 49. Which leaves a 1. I'll borrow another 0. Goes into that once, which gives me 3, which gives me 30. Wait, I started with a 30. And so if I continue, this is going to repeat. And this is a repeating. And so this isn't exact. I would say it's approximately 0.428571. Well, when you plug it on the calculator, your calculator is going to put this in, and then after this it's going to repeat. It's going to 285. And the calculator might run out of digits and round that up to 6. And so what we want to do is we actually want to round. We want to pick the best number that works for us. And so normally we will talk about so many decimal places to take. In general, 2's the rule of thumb, unless you're told a specific one. And so if I got this answer, I would have said, well, if I'm doing a percentage, I'd actually take 4. So I take back my, right? Depending on what you're looking at, you either take 4 or 2. Most of the textbook problems will say the nearest hundredth. But if we're doing a percentage or some type of ratio, 4 is a good rule of thumb. I had to put my context, so that's 4285. I have a 7 here, so I have to round that up. So I'm keeping the first 4, and if this number is bigger than 5, I increase this by 1. If it's smaller than 5, I leave it as is. So 4286. And so that's an approximate result. And so we're going to see to 4 decimal places, or it's 0.43 to 2. Again, depending on what you want. And so we're going to see that we sometimes have to approximate and we sometimes get exact results. When we approximate, when we round, we put the squiggly wiggly sign, the squiggly wiggly equal sign down. And so this is important in the way we communicate things. Some numbers just don't have exact forms that we can write. Sometimes we don't need to measure as accurate as a division is. And this pops up a lot with divisions. And so you have to get used to talking, is your answer exact or not, based on what's happening with your divider. Generally, if you fill your calculator screen, you're only going to report back part of it. And so you'll get the squiggly wiggly equal sign to say that it was approximately that number.